So today we're going to talk about present value and future value and kind of compare and contrast the two things and look at why we need to make sure that we're comparing some amount of money either in a present value or in a future value. So the idea is, would you rather have $1,000 today or in the future? And obviously you would rather have the $1,000 today because you can do something with it now. So $1,000 today would be worth more than $1,000 in the future. So perhaps let's say, what would $1,000 be worth at the end of the year if it earned 8%? Well, today it's worth $1,000. But in the future, it's not just worth 1,000, it's worth 1,000 plus the 8%. So we would say that's 1,000 times 1.08 is a future value of $1,080. So two different value amounts representing the same sum of money. Today it's $1,000, but we would want $1,080 in the future if we were going to wait a year to get this money. So the future value, which we define as being B, of a payment P is the amount to which P would have grown if it was deposited today. So in this case, that's where the $1,080 comes in. The present value P of a future payment B is the amount of money that you would have to deposit today to produce exactly B at the relevant time in the future. So here are the formulas. If we want to figure out future value, depending on if it's compounded annually or continuously, we're going to use these first two formulas. So these allow us to find future values. The formulas below allow us to take some kind of future value and turn it into present value. So this is for finding present values. And so when we're comparing payments, we want to make sure that we're comparing payments that are using the same time period. Are they using present values or are they using future values? So let's look at an example of that. We need to use this formula. So in this example, you have won the lottery and you can choose between two options. 4 yearly installments. So each year you're going to be paid $250,000 starting now, and at the total, at the end of that amount of time, you're going to get $1 million using these 4 payments. Or at this exact moment, you can get one lump sum of $920,000. So we're trying to answer a few things here. This $1 million, this is actually a future value, right? And in fact, each of those payments of $250,000 are future values. But this one lump sum of $920,000, you're getting that today. So that is a present value. So in part B here, what is the present value of option 2? Well, that should seem pretty obvious. We're getting $920,000 today. Okay, so what we need to decide is the $920,000 you're getting in option 2, is that worth more than in option 1? The problem is right now we can't compare those two because option 1 is a future value and option 2 is a present value. So what we're going to do is we're going to take option 1 and we're going to calculate its present value. So each one of those individual payments is going to have a present value. But to calculate this present value, we need to think about what kind of interest rate we're getting. So let's say in this specific example, we assume we can earn 6% compounded continuously. So we need to figure out what each one of these 4 payments is going to be worth. And that's going to give us our total present value. So I would say the present value of the first payment, right? We're getting 4 total, but the first one you're getting right now. So the first payment is worth $250,000 to you in present terms. So this is our first installment. The second payment, if we look back at slide 2, then the second payment would be equal to $250,000 e to the negative 0.06 times 1, because we've had 1 year pass, so t would be 1. So this is our second. The third payment would occur after 2 years have actually passed, so this would be $250,000 e to the negative 0.06 times 2, so this is our third payment. And then lastly, we get one more that would actually occur after 3 years, so $250,000 e to the negative 0.06 times 3. And so this is our fourth payment. Each one of these has a value. So I would say is the present value would be $250,000 plus the second payment would actually be worth $235,441. The third payment would be $221,730, and the fourth payment $208,818. And so we get a total that this is worth $915,989 in terms of the present time. So option 1 is really worth $915,989 to us, and option 2 is worth $920,000 to us. So we should actually choose option 2, and the reason is because it has a greater present value.